Yeah, that's not the answer. I thought you were just repeating what the table says. So this is asking for the enthalpy of the reaction. So enthalpy of the products minus enthalpy of the reactant, because this isn't a formation equation anymore. It's still a combustion equation, so you're still going to have benzene reacting with oxygen, producing carbon dioxide and water, but it's not a formation equation, so you can't just look it up in this table anymore. It's a reaction. Okay, do you have a question? You don't have your mole. Wait, what is this equation? Or a lack of money. You're on the right track, but I think that's the wrong way to write it.
Start off with the cells, but it was,
Actually, that might be right. 3,207. So change this to propane. So you're gonna have to remake the equation. Yeah. So just do everything and rework with propane. You did that? It's Friday, I know. Do you have any questions? Yep. What did you get an answer?
Well, I got that for the reaction we described, and then I put it into moles. The grams you gave us, and I multiplied it by the reaction to get the reaction with 1 gram.
Okay. This is slightly off. It's because it's not nice.
Yep, that's fine.
Yeah. Give me a question. No, I really didn't want it. But first, you can just rework the problem using propane.
Yeah.
And then do the formula. I think that's all. So you work them both the same way to get your change in enthalpy, and then you include more math at the end. Yeah. So the molar mass of propane is 44.1 grams per mole. And the molar mass of benzene is 78.1 grams per mole. You can also probably calculate those because carbon and hydrogen are ones that you might have memorized. So
Way off.
right, carbon's 12 and hydrogen's 12. Yeah, you were like 1,000 off. Yeah, carbon's 12 and hydrogen's 1. So like propane is 3 carbons, so 36 plus 8 hydrogen plus 8 would be 42. So close. Or carbon's 12. Yeah. Nitrogen's 14. It's all in there somewhere. Any questions? No, you're combusting benzene to carbon dioxide and water. So it should be benzene plus oxygen. Goes to carbon dioxide and water. Yeah. And oxygen, like pure element, has it will be a formation. So like hydrogen gas, oxygen gas, nitrogen gas. It's all zero. Noah, are those answers? Because they're pretty close, but you should be negative and they're slightly off. In a normal school year, I like play music, so it's not as like super quiet, but I don't want to like use everybody online.
I have another favorite place is.
I like it more, like I like the background noise, but online it might just be kind of weird. I don't know. They'll probably hear it a lot louder, because I can play it like on the computer. All right, do you guys have answers? You need more time? All right, then I'm gonna start going over it. Lunch. All right, so for this last equation, you are asked to calculate the standard enthalpy change. So this is enthalpy of a reaction, not a formation. So it's not like producing other, like using elements like oxygen and hydrogen gas to produce different chemicals like acetylene, but this we're actually like reacting equations or reacting chemicals in an equation. So we have to do the enthalpy of a reaction. So for this problem, the first thing that we do is we know that this is going to be our change in enthalpy at standard temperature and pressure of the reaction. And so this equation is the summation times the number of moles of the enthalpy of formation at standard temperature and pressure of our products. So essentially enthalpy of our products multiplied by their amount of moles minus the enthalpy, the summation of the enthalpy of our reactant. And then we are also told that we are reacting benzene in a combustion reaction, so we have benzene, which is C6H6. In a combustion reaction, which means they're reacting it with oxygen, to produce combustion products, which are CO2, this is gas, and water. So we know in a combustion reaction, we have a fuel plus an oxygen producing heat and energy and byproducts of carbon dioxide and water. So this is how combustion engines work. This is how parts of your car, everything will work like this. So we have this equation, fuel plus oxygen goes to carbon dioxide and water, then we need to balance it. So for benzene, the way that we're going to balance it, we're going to have 15 over 2 oxygen, 6 carbon dioxide, and 3 water. It's really important that you balance it correctly because then otherwise your multipliers are wrong and your answer is wrong. So if your equation is not balanced, your answer is never going to be right. Okay, so now we have our change in enthalpy of the reaction equation, which is going to be our enthalpies of our products multiplied by their molar amounts minus the enthalpies of our reactant. So in order to do this equation, we need to have the enthalpy information for all of these constituents. So here's where we're going to go to the table at the top. So first, we know that the enthalpy formation of oxygen is 0 because it's elemental. So nitrogen gas, oxygen gas, any of these elemental compounds have an enthalpy of formation of 0. Then we have benzene, which is C6H6, which is on this line here. You can't see that super well, but it says 49 kilojoules per mole. Then we have carbon dioxide, which is, we've looked at this several times before, negative 393.5 kilojoules per mole. And then finally water, which we've looked at in the last couple problems too, which is negative 285.8 kilojoules per mole. And now you also know like where these values are coming from, like where this enthalpy of formation is really coming from, because you calculated it to a certain extent. Okay, so we have all of our enthalpy of formation information. So these are our reactants. These are our products. So we know that this is going to be times 6. This is going to be times 3. And this is going to be times 1. Oxygen, it doesn't matter because it's 0. But so we're going to have our enthalpy of reaction, which is 6 times negative 393.5 kilojoules per mole. This is 6 moles plus 3 moles times negative 285.8 kilojoules per mole. This is for our products minus 1 mole times 49 kilojoules per mole plus 15 over 2 moles times 0 kilojoules per mole. This is for our reactants. So carbon dioxide, water, benzene, oxygen. So when you just plug in these values, you get negative 3,267 kilojoules. So this reaction is exothermic, which as a logic check, it's a combustion reaction. So if your answer is not exothermic, that should be a warning sign. Combustion reactions, some fuel reacting with oxygen producing carbon dioxide and water should always be exothermic, and it should be pretty high exothermic. It should be in the thousands. That's the point of combustion. Okay, so now you're asked to rework the problem using benzene. So if we were to change this equation, using propane. If we were to change this from benzene to propane, we would have C3H8, which is actually a gas, right? Propane gas. But it's still going to react with oxygen and go to CO2 and water. So rebalancing this equation, we would need to have, I didn't actually balance this yet. So 3 here, and then 4 here. And then what do you need in front of the oxygen? You need 5. So this is 6, this is 4. So 5 would give you 10, right? Is that what you guys all got?
Yes.
Great. Oh, you can see my my goddaughter's drawing in the background. All right, perfect. Okay, so now we have our new, this is for propane equation. For those of you who take my fundies, remember benzene is this ring structure, and propane, pro meaning 3, ane meaning it's unsaturated. So propane is this, I drew too much. This basic hydrocarbon with 3 carbons. All right, so we have propane that's combusting. We know we're going to get another negative value. It should be relatively close to this because it's just a different type of fuel. So we can do the exact same thing. We can actually even reuse this equation, but instead of having this as benzene, we're going to need to go to the table and look up propane. So all right, so now I have propane, and I can see it's negative 103.85. So now for this equation, I have my products, which are going to be 3 moles of carbon dioxide, which is negative 393.5 kilojoules per mole, plus 4 moles of water, which is negative 285.8 kilojoules per mole. This is for my products. And then I'm going to subtract my reactants, which is 1 mole of propane, which I just said was what negative, I already forgot. Negative 103.85 kilojoules per mole. And then water is, or oxygen is still 0, plus 5 moles times 0 kilojoules per mole for my reactants. The book doesn't actually work this out. So did anybody get a number here? Oh, wait, no, I do know what it is. This is negative 2,220 kilojoules per mole. Per 1 mole of propane. So for this equation, you could also just write negative 2,220 kilojoules because we're looking at 1 mole of propane. So yeah, once again, we're exothermic, we're in the thousands. It's a little less good of a fuel at producing heat. So if you're burning a fuel to get warm, try to burn your benzene over your propane, but honestly, don't burn benzene because you will maybe get cancer. So just stick with propane. Benzene's a carcinogen. Okay, so the second part of this question says, then compare the quantity of heat produced by combustion of 1 gram of propane compared to that produced by 1 gram of benzene. So these values here are for 1 mole. So now we need to include the fact that we are incorporating their molar mass. So we have for our propane, C3H8, which is a gas, we have negative 2,220 kilojoules per 1 mole of propane. And then for benzene, C6H6, which is a liquid, and it's lighter than water, so it like sits on the top of water. We have negative 3,267 kilojoules per every mole of benzene. And then the molar mass of propane is 44.1 grams per every 1 mole. And the molar mass of propane is 44.1 grams. The molar mass of benzene is 78.1 grams per 1 mole. So the moles should cancel. You can get kilojoules per gram. So the amount of energy for the amount of fuel. And this is going to be negative 50.3 kilojoules per gram for propane. And this is going to be negative 41.8 kilojoules per gram of propane, benzene. So this is for propane. This is for benzene. So even though the burning of benzene produces more heat in the reaction, the molar mass is higher. So actually on a gram basis, propane is a better fuel. So this is like when you go to Publix and you can either buy 18 eggs or 12 eggs, and you got to kind of check like what's the price per egg, right? What's the energy per gram to really compare them, not just the overall reaction, but the overall price. Okay, so that's all I had set up for today. Are there any questions about enthalpy, enthalpy of reaction, enthalpy of formation, enthalpy change, anything?
So we would always be given the mole mass.
Yeah, I don't expect to memorize all that. Yeah. I mean, worst case, I would give you a periodic table, but this is a chemistry, so I would tell you the mole mass.
And like for like propane,
I would give you the chemical formula. You should be able to draw it from Bundy's, but I know you haven't taken it yet. And it's not actually a prerequisite class, so I would give you the perfect. And then, oh, so next week we're starting on Gibbs free energy. So look forward to that on Monday. Thank you, everybody. Yeah, kilojoules per gram. Yeah. Oh, well, let's, if we just need one K there. Kilojoules per gram. Congratulations.